Now we're going to look at rationalizing the denominator. Now, you may have heard of rationalizing the denominator, or you may not have even looked at surds before. So it's really important that I get to spend this time to go through this. If you understood this already, see it as a recap. If you haven't seen this before, make sure your attention is on full. So it says, here's a surd. What could we multiply it by such that it's no longer an irrational number? What could you multiply the square root of 5 by so that it's no longer irrational? Ismail, you could multiply it by root 5. If you decided to multiply this by root 5, we would get the answer not 25. We would get the square root of 25, which is 5. So it's no longer an irrational number. However, what I've done here, I've actually changed the number, okay? I've changed it from root 5 and I've multiplied it by something. It's no longer the same number because I've multiplied it by a new quantity. So we're going to look at something different. I've got a fraction down here and the denominator is irrational. Rationalizing the denominator means making the denominator a rational number. Well, what could we multiply this fraction by to both rationalize the denominator but leave the value of the fraction unchanged? So here, we made it become rational, but we also made it root 5 times bigger. It's no longer the same number. So here I need to think of what can I multiply the fraction by that won't change the size, but will rationalize the denominator. Ikram.
Root 2 over root 2.
Good. Why is multiplying by root 2 over root 2, why is that not going to change the value of the fraction or the number?
Because it's all root 2.
Yeah, so tell me more. What is root 2 over root 2? How is that not changing the size? Abdi?
Because it equals 1.
Good. Root 2 divided by root 2 is 1. What happens when you multiply by 1?
Stays the same.
Stays the same. So when we talk about, lower down in the school, I would say like, oh, come up with an equivalent fraction to a half. And someone would go like, oh, multiply it by 3. And they would say 3 over 6. But they're not actually multiplying it by 3, are they? They're actually multiplying the numerator and denominator by the same thing. That's exactly what's happening over here. We're not multiplying it by root 2. We're multiplying it by 1. But the trick is we're multiplying the numerator and denominator by root 2. So 1 divided by root 2, with fractions, you just multiply the top. So you get the square root of 2 over, what's root 2 times root 2?
2.
2. We've got the square root of 2 divided by 2. It's a half of root 2. So I've said, why would we want to do this? Because this just feels like something completely random we've decided to do. Well, one of the reasons is for aesthetic reasons. Aesthetic means like how the thing looks. It makes more sense to say a half of root 2 rather than saying 1 root tooth of 1. That doesn't really make sense to kind of say that. It's much nicer generally to divide by something that is an integer, because I'm now saying this is the square root of 2 shared between two people. I suppose in a separate way you could have written it if you really wanted to, was a half root 2. But this is rarer. We don't tend to write it like this. We much more commonly will write it as root 2 over 2.
So can you possibly make that whole integer?
No. If you make the whole thing become an integer, then it would be a rational number, and it is not a rational number. Irrational numbers have a special property that they cannot be turned into rational numbers, okay? The second reason is if they are rationalized, if the denominator is rationalized, it makes it much easier to add expressions which have surds in them, okay? And you'll see that with some examples, that if you have it like this, they're very hard to add them up. If you have it looking like this, they're a lot easier to add up because you have integers in the denominator. So for now, there's not going to be some super real life reason why we need to do this. It's just learning skills that will help us access higher maths in the coming months. So we've got a few here. I'm just going to do these 3, and then you're going to have a go at these 3 in just a second. So this first one, I'm going to multiply the top and bottom by the square root of 2. So when I multiply the top by root 2, I get 3 root 2. When I multiply the bottom by root 2, I get 2. So I rationalized the denominator. I concentrated on what the denominator was. It was root 2, and I decided I would multiply it by a root 2 to rationalize it. So what am I going to multiply the top and bottom by here? Sufyan?
6 root 3.
6 root 3
Over 3.
over 3. What can I do now? There's more that can be done here. Yes?
Multiply over 6 by 3.
Good. This is 6 divided by 3, which is 2 root 3. So you can start to see that rationalizing the denominator we've got 6 divided by root 3. It's actually something like 2 root 3, which was coming up in those previous questions. So it's more useful to do that because it might allow us to simplify some things and put them together. So we've got 7 divided by root 7. What's 7 divided by root 7 going to be? 7 root 7 over 7, which is just root 7. Now, can you try and explain to yourself why, and think less about the symbols and things, try and think about what it means. You have 7 divided by the square root of 7. Why is the answer the square root of 7?
Because when you rationalize it...
Nothing to do with anything to do with rationalizing.
Because it's magic. It's basically like counting it by himself. No.
Because it's being divided by its root, so it's going to get its root.
Yeah, exactly. If you think about what we're actually saying, if we have the square root of 7 times the square root of 7, so obviously 7 divided by the square root of 7 is the square root of 7. Yeah? So it kind of makes sense when you're saying it's 7 divided by the square root of 7.
4 divided by root 2. No, wait, no. 4 divided by root 4 is basically the same as 4 divided by 2. That makes it 2.
Yeah, but that's not quite what I'm meaning.
No,
I'm
that makes
just...
sense, though.
I'm happy for you to think of this as just rationalizing the denominator, but it's also interesting to think if you're dividing by the number's square root, you're going to get the remaining square root that would have multiplied by it.
But then yeah, but
So,
root 7 is harder to find. An easier way to just show is like 4 divided by root 4. Like
no, but I deliberately want it with root 7. I want it with a third number. But anyway, it's all good. Okay, so I'm not going to be able to do, I want to do just one part of this rationalizing to begin with. So Manayam, what am I going to multiply the top and bottom by here for this first part?
15 root 5.
So I'm going to get 15 root 5 over 5 for this first part. And I'm not going to do anything to the next root 5. I'm just going to leave it there like this. Zainab, what does 15 root 5 divided by 5 simplify to? Good, so I've got 3 root 5 plus root 5. And then Zakia, what is 3 root 5 plus root 5?
4 root 5.
Good, it's 4 root 5. It kind of behaves like algebra, like 3a plus a is just 4 root 5. So you've got 3 of them to try here. I'm just going to give you probably a minute and a half to try these ones, and then we'll go through them on the board together.
Can I make it a third?
Yes, you should, yes.
So
Yep.
is this y?
Yep, so you want s to be...
Less than or equal to 0.
Good, good, because they're both negative powers. If s is negative, it then becomes a positive power, and it becomes an integer. Good, very good, well done.
Yeah, no, so 2 root 2.
Okay, probably about 30 seconds more here. Okay, so first of all, think about how would you rationalize that denominator? You've got it here. Yeah, this is good. So all you need to do now is split it into 2 bits. So you're going to have one of the fractions is like this, 25 root 3 over 125, and the other one is going to be 25 root 2 over 125. Pull it apart into those 2 separate ones, and then simplify them. Yeah, but as it wants it as A and B, it will be... ooh. Let me just quickly do this bit and then I'll come back and go through it with you, okay? Okay, so we've got these ones we want to have a quick look at. I'm sure we've had enough time here. I'm going to pick Abdurrahman first of all. 12 over root 3. What did you get for your first line, the first bit of working?
Oh, I haven't actually done that yet.
Okay, no problem. Jamil? 12 root 3 over 3, which is? 4 root 3. Okay. I'm going to ask, yeah, Ikram, 2 over root 6.
2 root 6 over 6.
2 root 6 over 6, which is?
Third root 6.
Which is a third root 6. I'm going to actually write it as root 6 over 3, just because that's just the way that people tend to do it. If you wrote it as a third root 6, that's also correct. You could write it as a third root 6. This is just the more common way of writing it.
Equals root 6 over 3.
Because the 2 and the 6 simplifies as a fraction. 2 over 6 simplifies to 1 over 3. And then we've got 4 root 2 over root 8. There's a couple of ways we could go about doing this one. Isma, did you get this one done? Okay, no problem. Did you get this one done, Zainab? Yeah? So you have 4 root 2 multiplied by the root 8 over, and so you said it's 4 root 16 over 8. So this is 4 times 4, which is 16, over 8, which is 2. So the answer is just 2. Yeah? There's another way of doing it. So I want to hear, Manayam, what was your way of doing this?
I changed root 8
Shh. So he changed root 8 to 2 root 2,
divided by 2.
and you can divide by the root 2 there, and then you've just got 4 over 2, which is just 2. So I prefer that method. So although we're learning about rationalizing the denominator, it's also useful to do simplifying, because if you do that simplifying, then the root 2's cancel and you immediately get to the answer 2. So just because I'm teaching you this thing, it doesn't mean rationalizing the denominator is better than the other things. It's just a different tool that you have, and your skill is going to be telling me what tool you need to use for what part of it. Okay? So these are quite simple, rationalizing the denominators. We're now going to think about more complex denominators that we might have here. So I'm going to try and rationalize this more complicated looking denominator. It's more complicated because it is no longer just a surd. It's a surd plus something else, or a surd minus something else are going to be what we're looking at here. Does anyone have any suggestions? Does anyone know what we multiply by to rationalize this denominator? Ikram.
You still multiply it by root 2 plus 1.
If you multiply it by root 2 plus 1, we get a bit of a problem. And I'm just going to show you, even if you know what's going on, I'm just going to show you why it's a problem. So when you do the denominator, you would have the root 2 times 2, which is 2, the root 2 times 1, which is root 2, the root 2 times 1, which is root 2, and the 1 times 1, which is 1. So the denominator becomes 3 plus 2 root 2, which still has an irrational number in it. So what's the suggestion then, Ikram?
I think it's root 2 minus 1.
It is root 2 minus 1, okay? So the thing we're going to multiply by is the same as this expression, but changing it from a plus to a minus, or from a minus to a plus. There's a phrase that I would say that I'm going to negate it. Whatever this bit is, I'll negate it to turn it to look like this. Now, when I do this expanding, personally, I like to throw around some brackets because it just reminds me that I'm going to be doing the double bracket expansion. There's something in my head that when I put the brackets around it, it reminds me I've got to do this times this, this times this, this times this, and this times this. So first of all, the numerator is dead easy, but if it wasn't a 1 there, you would have to make sure you did the number multiplied by each part separately. So the numerator will be root 2 minus 1. And then the denominator is a very special combo here. Does anybody remember what this special combo is, where you've got the two numbers that are the same, or letters, and one is with a plus and one is with a minus? Does anybody remember what this is called, though? It is called, Zainab? Good. It is called the difference of two squares, okay? The difference of two squares. We'll be coming across that a few times. I'm also going to mention it down here at the bottom as well. So when you do these, you would have the square root of 2 times the square root of 2, which is 2, and then the square root of 2 times minus 1, which is minus root 2. You then get the 1 times the root 2, which is plus root 2, and then you've got the 1 times by the minus 1, which is minus 1. So they cancel out, and what you end up with is root 2 minus 1. These cancel over 2 minus 1 is 1. So you get root 2 minus 1. It's not actually a fraction anymore. We've rationalized the denominator, and it's no longer even a fraction.
Why is the
Because you've divided by 1. Now, this is because what I've got written down here in this red box is we basically use the same expression as this, but with the sign reversed. And this is something that we call the conjugate. Okay, the same expression but with the sign reversed in the middle is called the conjugate. And the reason this is because we then obtain the difference of two squares, and that is because that a plus b multiplied by a minus b is a squared minus b squared. So any surds will be squared, and thus we'll end up with no surds in the denominator. Now, although I did this long bit of expanding here, the shortcut to expanding this is just saying it's this one squared minus this one squared. Okay, because that's what happened. We had this one squared minus the other one squared. Yep, because the middle bits are always going to cancel out. The middle bits are always going to cancel out because of it being the difference of two squares. So we're going to just do a couple of examples, and then you'll do some practice. So let's have a look at this. We've got 3 over root 6 minus 2. So I'm going to multiply the top and bottom by root 6. No, root 6 plus 2. Root 6 plus 2. And again, I like seeing these brackets because they remind me about how I'm going to do all of this expansion. So I've said in this box here, you can explicitly expand out those double brackets in the denominator. But remember, because it's a minus b, a plus b, because these are difference of two squares here, it's just going to be equal to a squared minus b squared. So we can mentally do this in our head. So it's the difference of two squares. It's got to be them subtracted. So the denominator is going to be the root 6 squared, which is 6, minus the 2 times 2, which is 4. So we can avoid having to do all of that expansion and save us a little bit of time. And what about the numerator? Minhaj, what's the numerator going to be for this fraction?
3 root 6 plus 6.
Good, 3 root 6 plus 6. So then this simplifies to 3 root 6 plus 6 over 2. Okay? Because I have just done the 6 minus 4. Now, if I wanted to, because some questions might ask you to present it in a particular way, I could take these two pieces and I could pull them apart into two separate fractions if I wanted to. So I would have 3 root 6 over 2 from this section, plus how much? Plus 3, because I've got 6 over 2. So if you want to, you can have them separate. If you want to have them together, you can have them together. The question might tell you how it wants it to be presented. Okay, let's try this next one. Zakia, what do you think I'll multiply the top and bottom by here?
Root 3 minus 1.
Good, root 3 minus 1. It's the opposite, because if you do the opposite, you create this pattern that happens, where you have 1 squared minus the other 1 squared. When you go back over your notes later, if you read through this section down here again, it will remind you why it's the opposite. Okay? So let's expand the top. Who's going to expand the top for me? Sufyan, are you doing it now?
Is it root 3 plus? No, wait.
For the numerator, we're going to do the 4 multiplied by this and this.
Oh, wait, I'm confused.
Okay. Someone else can do it. It's not a problem.
4 root 3
Yep.
minus 4.
4 root 3 minus 4. And anyone think they can see what the denominator will be? Jamil? Sorry? Yeah, it's going to be 3 from this one times this, minus this one times this, which is 1. So it's going to be a 2 on the denominator. So that's 4 root 3 minus 4 over 2. And what does that simplify to? 2 root 3 take away 2, because you can divide this by 2 and you can divide this by 2, because that's what the instruction is telling you to do. So the answer is 2 root 3 minus 2. So we've got one more here before you guys are going to do a couple of them as practice. So we've got 5 root 2 minus 7. Hamza, what am I going to multiply the top and bottom by for this one?
5 root 2 plus 7.
Good. 5 root 2 plus 7 all over 5 root 2 plus 7. I'll add in some brackets. So this is going to be a bit longer. Why is this one a bit longer? What's different that's going to make it a bit longer?
Surds on top.
Yeah, the surds on top as well. Here we just had integer, integer. We've now got a longer bit here. So you're going to need to concentrate as we expand the brackets on the top. So you've got to pay attention here. 3 root 2 times 5 root 2. See if we can do that all in one go. 3 root 2 times 5 root 2. So it's 15, and then we've got root 2 times root 2 is 2. So it's 15 and 2, so it's 30. Now I'm going to do 3 root 2 times 7,
So that's 21 root 2.
that's 21 root 2. Now I've got 4 times 5 root 2,
20 root 2.
good, 20 root 2, and then I've got 4 times 7, 28. Okay. Now at the bottom, we're going to try and do that shortcut where it's going to be this one times this one minus this one times this one. What's 5 root 2 times 5 root 2? 25 times 2, which is 50. And then 7 times 7 is 49, and we're subtracting it. So, the denominator is 1. So I'm not going to bother doing denominators anymore, because as soon as it's 1, it's just dividing by 1 is boring.
How do you get 50?
50 is because it's 5 root 2 multiplied by 5 root 2.
Yeah.
5 times 5 is 25.
Oh, then
Root 2 times root 2 is 2. 25 times 2 is that. And we didn't bother doing this times this or this times this because they were going to cancel out. So we've stopped bothering doing that when it's a difference of 2 squares. Save time. So the numerator simplifies to 58 plus 41 root 2. Done. Okay? So I'm going to leave it on this page, but you've got 3 questions that you can have a go at here, and then we'll go through them in just a bit. Yeah, we're going to leave it on this page.